In this video, we are going to review different types of banking that you've learned about so far in your math career. So example 1 says Selena has $300 in her savings account and makes a $50 deposit every month. So is this situation linear or exponential? You're adding $50 every month, and that is a linear pattern. So this is linear. So this example would create a line if we were to graph it. Then it says write the equation of the model. Well, here I can use slope-intercept form, y equals mx plus b. She's depositing $50 every month, so I'm going to have y equals 50x. And our starting amount per y-intercept b is $300. So this would be her equation. Part C says how much money will Selena have in 3 months? So that means that x is 3. And so I'll have y equals 50 times 3 plus 300. So y equals 150 plus 300, which will give me $450. So after 3 months of savings, Selena will have $450. Example 2, Samuel has $300 in his savings account and increases his savings by 15% every month. If you're increasing by a percentage, then that makes the model exponential. If you were to graph this, you would have an exponential growth curve. Now, we learned lots of different equations, and for this one right here, I would use the formula A equals P times 1 plus or minus r to the power of t. Now, it doesn't say anything about compounding. That's why I did not use the compound interest formula. It also didn't mention compounding continuously, so I did not use that formula. Here we are increasing, so I would use a plus sign. So my equation would be A equals, his initial amount is 300 times 1 plus our interest is 15%, or he's going up by 15%, so that's your rate. So 15% is 0.15 as a decimal raised to the power of t. You could write this as your formula, or you could say A equals 300 times 1.15 to the power of t. These are the same thing. The only thing I did differently was here I left it as addition, and here I did find that sum. Part C says how much money will Samuel have in 3 months? So I'll have A equals 300 times 1.15 raised to the third power. And if I do that in Desmos, let's see, I'll have 300 times 1.15 raised to the power of 3. We're talking about money. Money has 2 decimal places. So if I round this to the nearest hundredth, I'll have $456.26. And then part D says who is saving more money, Samuel or Selena? So Selena has $450 and Samuel has $456.26. So who has more money? Samuel. Now, when we're talking about compound interest, these are the different formulas that we learned about. If you're compounding over n compounding periods, then this is the formula that you're using. If you're compounding continuously, then this is the formula that you are using. These are your different values of n, and this is what all of those variables mean. This is what we went over back when we talked about exponential equations and functions back in Unit 5. So example 3 says Elijah plans to put the money he has saved into a bank account that earns 2.3% interest compounded semi-annually. He has saved $500. How much money will be in his account in 6 years? So he's compounding semi-annually, so that means I'm going to use the formula A equals P times 1 plus R over N to the N times T power. His starting amount is $500. His interest rate is 2.3%, so as a decimal that's 0.023. If we're compounding semi-annually, then that is twice per year. And that will be raised to the 2 times 6 power, because we want to know that will be in 6 years. So I'm going to go back over to Desmos, and I'm going to type in 500 times 1 plus 0.023 divided by 2. And then I'm going to use my exponent button. And remember with Desmos, if you have more than one thing in your exponent, you have to use parentheses. We're talking about money, so we're going to round to 2 decimal places. And so this will be $573.54. And then on example 4, it says Bree plans to put the money she has saved into an account that earns 4.25% interest compounded continuously. She has saved $250. How much money will be in her account in 3 years? We are compounding continuously, so we want to use the continuously formula, which is A equals P times E raised to the power of RT. So we're going to have A equals, her initial amount is $250 times the natural number E. Her interest rate is 4.25%, so that'll be 0.0425. And then she wants to leave it in that account for 3 years. So I'm going to come back over here to Desmos and type in that equation. So 250E raised to the power of 0.0425 times 3. Again, I'm talking about money, so I want to round to the nearest hundredth. Here I have $283.99. So this technically, if we're rounding because of money, then this is actually going to round up to $284, because when I look at that third decimal spot, that's higher than 5, which rounds up the 9, which rounds up the dollar. So this is going to be $284.